Hello, welcome back to this presentation of International Plumbing Code, Chapter 6, Water Supply and Distribution. My name is Thomas, and this is part 2. We're going to pick up where we left off. We'll start in section 605. Let's check it out. In 605, we look at materials, joints, and connections. We're talking about what kind of pipes can we use and how do we put those together. 605.1 talks about soil and groundwater and helps us to understand the fact that if a pipe is put into contaminated soil, let's say it has chemicals in it, that could very adversely affect the pipe. I mean, it could contaminate the water. So we have to be conscious and careful of what is the ground like that we're putting these pipes into, and obviously not install them in any contaminated soils. Speaking of contamination, there's a lot of four-letter words out there, but one of those is lead. That's become a very bad word because, well, I guess we've come to understand that lead poisons the brain, and nobody wants that. So lead content in water supply pipe and fittings is limited, very limited. 8% is the most that it can contain. You know, there was a bit of a movement there where the government pushed to get lead out of all brass alloys. Well, valves are made out of brass. Many plumbing fittings and things are made out of brass. So when they removed the lead, and there's not a lot of lead in those alloys, but when they removed it, those manufacturers had to come up with, you know, a metal alloy that could still function, but without the lead. And there was a little period where I think it was questionable. I personally installed a valve into someone's house, a very reputable brand, one that I'd used for years and would still use now. But after a year, just pinhole leaks started shooting out the side of the brass body of the valve and flooded someone's basement. My point is that government is going to restrict the amount of lead because it's such a bad word. Well, I guess it's a bad thing. But let's not talk about the fact that all through the 1970s and such, copper water pipe was assembled with 50-50, meaning like half of the solder was made of lead, and that's still in all the water systems that are out there. Don't worry about that. Let's move on. 605.3 talks about the water service pipe, some specific requirements that it would have to meet in order to be a water service pipe. Namely, it has to be able to hold 160 psi at 73 degrees Fahrenheit, or the minimum rating equal to the highest available pressure. So what that means is this pipe has to be able to hold high pressures at normal temperature, right? Now when I say normal, look at 605.4, water distribution pipe. Now we've left that pipe that brings water into the building and we're distributing throughout the building, and there's a different requirement. It says 100 psi at 180 degrees Fahrenheit. Please note that 180 degrees Fahrenheit is much higher than 73. What we're looking at is the fact that when pipe is hot, the strength of that pipe diminishes. It will not be as strong if it's like superheated. So that means if we're going to use pipe on the inside of the building, we don't want these to burst when we're starting to run 120 degrees, 130 degrees, 140 degree water through those pipes. They have to be strong enough to hold 100 psi at 180 degrees Fahrenheit. That should hold, and that's why they require that. 605.5 tells us that the fittings that we use for water pipe systems must be approved, and that's kind of what a lot of this section 605 is about. There's long lists of standards that pipe and fitting would have to meet on tables. So just be aware that in general that's what we're looking at, is like we want it to meet a standard of quality, and they're going to detail out the standards that enforce that. 605.5.1 talks about mechanically formed fittings. This is the T-pullers. You can go into a copper pipe and actually mechanically form a connection point. And it's not as common these days, but it is possible. And if that's the case, then the height of that connection point would be not less than 3 times the thickness of the branch tube wall. The 605.6 tells us that any time we use a flexible water connector, it must be accessible. Now remember, accessible means it could be behind a panel or in a cabinet or something, but we have to be able to get to it to service it. 605.7 gives us a list of standards for valves. And when it comes to manufactured pipe nipples, 605.8 gives us a table that gives us standards for those. There are a few connections that are absolutely prohibited by code. This is 605.9. It says the following are not allowed: cement or concrete joints, not to be used with water pipe; joints made with fittings not approved for the specific installation; solvent cement joints between different types of plastic pipes, so you're not going to use the wrong glue for this or that type of plastic, or mix different types of plastics, fittings, and pipe. And finally, saddle type fittings. You know, if I were to guess, of all the code violations that exist in the world, which ones are the most common? Saddle type fittings got to be high on the list. They're not allowed by code, by any code that I know of, and yet people saddle pipe all the time. Saddling means that you just poke a hole in the side and put this clamp with a rubber seal on it. Now come on. That's the lazy way to get this done. We can cut this and put in a fitting and do it right. Anyway, as a professional, you shouldn't be installing saddles. Ever. From 605.10 to 605.24, there are lists of materials that can be used, pipes that can be installed for water piping, and it details out how you can install each of those. It will list out the different ways that you can connect that pipe. We're not going to take the time to go through all of that, but it's important to know that there is a section within this chapter that covers it. Here's a list of the pipes that are in that section. ABS pipe can actually be used for water pipe if it's a solid wall and meets certain standards. Brass, common for water pipe. CPVC, copper. PEX, PEX aluminum PEX. Ductile iron, galvanized steel. Polyethylene, polypropylene, and stainless steel. One that you will notice not on the list is polybutylene. Oh, we must never forget the fact that discovery is an ongoing process and sometimes involves failures. Polybutylene is one of those failures. Early on, when we started using plastic tubing for water pipe, it was a great idea and still is, but we just didn't quite have the tubing right. Polybutylene was installed in the 1980s. It was the early versions of what we do with PEX, where there's a barbed fitting and a crimp ring, and you push it into the tubing and you crimp the ring. But the problem was that the pipe itself was not very durable, and within a decade, there were so many flooded houses that there was an actual recall nationwide on polybutylene, and they said, yeah, stop the train, we can't install this ever again. And we haven't since. But there are still very many houses today that have polybutylene piping installed as their water distribution system. And they're just a ticking time bomb. You know, at any moment they could just flood the house. Let's move on to section 606, installation of the building water distribution system. Now we're focusing on that system inside the building. First of all, what do? You install a valve. That service line comes in and you install a valve. So that's what we're going to look at first. Full open valve, 606.1. Where do you need a full open valve? And when I say full open valve, I'm talking about a valve that does not restrict the flow. You can get valves with a reduced opening, and that's going to restrict the flow. But when it comes to distribution, we want to make sure we get enough water flowing through that valves are not a huge restriction. They'll always be a restriction, but not a huge restriction. So here's our list. Number 1, the building water service pipe from the public side. So at the curb, at the meter, you're going to want a full open valve there. Once it gets inside, number 2, you're going to want a full open valve at the entrance. Number 3, on the discharge side of every water meter. Well, sometimes people have water meters on the inside of the building, not in my state, but obviously if you have a water meter inside, you'd want one on the other side of that meter. At the base of every riser, if you're in a tall building and these water pipes are shooting way up to other floor levels, you want to be able to isolate, so you have valves there. At the top of every down feed, I've seen that too. Water goes up to the top of the building and feeds down, or maybe it comes from a tower on the roof. that's where you would want a shutoff valve as well. Number 6, on the entrance to every water supply pipe to a dwelling unit, meaning if you have a series of townhouses or a group of homes that are all in the same building, you'd want an individual valve for each space. Number 7, on the water supply pipe of a gravity pressurized water tank. Again, if there's a tank on the roof or if there's some way that we're feeding water from a tank, definitely need a valve there. And finally, number 8, on the water heater. We want full open valves to the water heater so that can flow through without restriction. There are also other places that you would want to have shutoff valves. 606.2 talks about those. Number 1, on the fixture supply of every plumbing fixture. Sinks, toilets, anything we connect should have a shutoff valve. We call them stops. We put them in cabinets. We put them behind the toilets, but they should have that. Number 2, there is the requirement for a shutoff valve on the water supply pipe to each sillcock. A sillcock is an outside hose faucet. So they have to have a way to isolate that. Every single one. Oh, I've seen way too many plumbers who just run the pipes through the house. They branch off for cold here, branch off for cold there, send one off to the outside hose faucet with no way to shut it off. You have to have a valve for those. And number 3, on the water supply pipe to each appliance or mechanical equipment, obviously dishwashers, water heaters, washing machines, all of that. We need shutoff valves. 606.3 states that we have to have access to these valves. Many times they're going to be hidden, maybe in an access panel in the wall or in cabinets or other places, but we have to be able to get to them, and we definitely need to be able to identify them as stated in 606.4. Service valves and hose bibs have to have identification, and especially if the valve is not adjacent to the fixture or nearby the fixture. If you can't tell what it shuts off, you definitely need to label that. Labeling can be as simple as taking out a Sharpie and writing on the handle or on the pipe next to the valve. It does not have to be a difficult thing, but it should be done. 606.5 gives us information about water pressure booster systems. This is where if you don't have enough water coming in last presentation I mentioned, what if it's at 25 psi from the city? Well, then you can boost it up. You get a tank, you get a booster pump, and you push. That's what this is all about. 606.5.1 talks about the water pressure booster systems that are required. This section details the support, the covers. It also gives overflows for water supply tanks, 606.5.4. So depending on the size of the tank, you're going to have a certain size pipe for the overflow. 606.5.5 talks about the low pressure cutoff where required on booster pumps. This is an electric switch that's going to shut off the electricity on the suction side of the pump if the pressure is 10 psi or less. This keeps the pump from burning out. 606.5.6, potable water inlet control and location is detailed. The auto supply valve is to prevent overflow. 606.5.7 gives us a table that details the size of drains for a water tank. These are the big water tanks that we might use in places where there are not mountains to deliver water. So if you have a large tank, you're going to need to be able to drain that quickly. And again, depending on the size of the tank, you would have a certain drain pipe diameter. 606.5.8 talks about prohibited locations for potable water supply tanks. Namely, you don't want them below a soil or waste pipe. You just don't want any of the risk of possible drainage waste getting onto or into the tank. And so we keep it away from those types of drain pipes. 606.5.9, pressure tanks do have certain ratings. They have to be able to handle 200 psi at 200 degrees Fahrenheit. And the size of the vacuum relief valve would have to be not less than ½ of an inch. For 606.5.10, pressure relief valves for tanks have to be the maximum equal to the tank rating. The pressure relief valve on the tank must be set to the maximum pressure equal to the rating of the tank, and it has to be on the supply tank or on the tank itself. Moving on to 607, we look at the hot water supply system. Where do you have to have hot water? Well, code says any fixture that is supposed to have hot water should be supplied with hot water. That includes bathing, washing, culinary purposes, cleansing, any of those fixtures. In non-residential occupancies, this is an important point. That means public space. Hot water or tempered water shall be supplied for bathing and washing purposes. 607.1.1 talks about temperature limiting mains. This is where we use a valve to restrict the heat of the water, a mixing valve, for example. And it states that if we're going to have a limit to the temperature of the hot water, we cannot rely on the water heater itself to limit the temperature of the water. Why not? Well, you can set a tank type water heater to a certain temperature, but does that mean that's what it's going to do? It's going to deliver? It can fluctuate. So we can't rely on that. And therefore we have to have some way of mixing it down in a way that we can control that. 607.1.2 talks about the tempered water temperature control. And if we're going to use a temperature limiting valve, then it has to be set to no greater than 110 degrees Fahrenheit. There are a number of standards listed there and options for limiting water temperature. 607.2 goes over a requirement that is very important to understand, is dealing with the length of time you have to wait to get hot water at a fixture. If you wait for a long time, then you're wasting energy. You're going to be losing hot water along the way as it travels, plus you're wasting water. So the idea here is to minimize the wait time for you to get hot water, and there's different ways that we can do that. But to start off, they say the limit is from the heat source, that's your water heater, to the fixture where you're using hot water, that cannot be further than 50 feet without having a recirculation system. So this answers the question of when do you need a recirculation system? Well, anytime you're more than 50 feet away from the water heater. It used to be 100 feet, but they're trying to encourage energy efficiency. And you'll find in the 2021 International Plumbing Code, there's quite a bit more in here, and it's referring us often to the energy code, where we're trying to save energy. Now there's two options for getting that hot water out to a fixture quickly. One is a recirculation system where a pump is pushing that hot water out and bringing it back to the water heater. The other is a heat trace system. In 607.2.1, the code refers us over to the International Energy Conservation Code and gives us a number of standards from that code that these recirculation systems would have to meet. 607.2.1 gives us information about the pump controls for hot water storage recirculation systems. So here's how it works. When the water heater heats, it goes through a cycle. At the beginning of that cycle, the pump can come on and it can push water. But the pump should stop within 5 minutes after the water heater stops heating, so that that pump is not constantly running. All pumps nowadays that are installed should not be running constantly. They should only run to move that hot water out to the fixtures and then stop in between. Another method for getting hot water to fixtures quickly is to have a demand recirculation system. Now these systems are good if you don't have a recirculation line. If you only have a hot and a cold, how do you get hot water out there faster? Well, the idea here is that you can draw hot water through the hot side and push it back through the cold side with a pump. And once the hot water gets to the fixture, you'd want to stop pushing hot water into the cold side. That's where this 607.2.1.2 limits the degree of temperature of water pushed back into the cold side to 104 degrees Fahrenheit. Don't want to be melting any toilet wax out there now, do we? The pump generally starts functioning when the fixture is in use, and that enables a shorter wait time for hot water. This is energy conservation. There are also temperature actuated recirculation systems. 607.2.2 gives us information about the temperature actuated recirculation valves. These will open up as that water cools down, allowing the circulation to flow through. These are pushing hot water back through the cold, as with the other system, but when that hot water reaches a certain temperature coming through, it will automatically shut off. If you're going to have hot water, you're going to have expansion. As water heats up, it expands. If it doesn't have anywhere to go, it drives the pressure of the system up. So the expansion tank is one option for handling thermal expansion. 607.3 requires that we do something to handle that expansion of water as it heats. This becomes particularly important in a system that is closed, meaning that water comes in from the city and then it passes through a check valve or a pressure reducing valve or a backflow preventer, and it can't go backwards, so the system is locked. Now all the water that is in there is stuck. as the water heats up, of course, it drives the pressure up, and that is bad for everything in the system: valves, faucets, and especially water heaters. The code says you need to make sure that your expansion tank fits the size of your system, particularly that it can handle the amount of water in the system and the size of your water heater. 607.4 is a very short paragraph, but it is what keeps us all on the same page. This is in reference to where you can find hot water handles. It specifically states that hot water is going to be on the left. If you're ever wondering which valve will turn on the hot, always to the left. It's important as plumbers that we install with the hot on the left side. Now, the only exception for that is kind of obvious, and that would be shower valves. Some may have a different operation, but that has to be clearly indicated on the shower trim or handle. 607.5 talks about pipe insulation and refers us again to the Energy Conservation Code. There's quite a bit more detail in the International Energy Conservation Code. We'll leave it at that for this presentation. Alright, at this point, if you'll jump with me forward in the code to 609. 608 is all about backflow prevention, and there's so much there, so much to cover, that we're going to do an entirely separate presentation just to cover backflow prevention. But let's move forward to 609, and we'll finish off the chapter from there. In 609, we're talking about healthcare plumbing. Now, there used to be a lot more in the code about this, but because healthcare is so regulated and the installations of things in healthcare systems are also regulated, the code is just covering some of the basics that really apply to plumbing. And so what we get is, in the scope it says, this section shall govern those aspects of healthcare plumbing systems that differ from plumbing systems and other structures. So they're saying, well, plumbing is plumbing, but here we're dealing with healthcare, so there's going to be a few things that are a little different. Those differences apply specifically to certain occupancy groups. Group I2, Condition 2 facilities are specifically named. There's Group I1, I2, and Group B that, if you go back into Chapter 4, that's where we learn about occupancies and the number of fixtures and types of fixtures that are required for certain types of buildings. That's what we're referring to here. Jumping to 609.2, it talks about water service. It says that in these types of buildings, we're talking healthcare types of buildings, those buildings shall have not fewer than 2 water service pipes sized such that with the loss of the largest pipe, the remaining service pipes will meet the water demand for the entire facility. Let me explain. In a healthcare facility, there may be people whose very lives depend on the flow of water. If that is not available, if the service line goes down and there's no water to the building, people could possibly die. For that reason, there are 2 service lines installed. If there's a problem with the main service line, that can be shut down, and the other should at least be big enough to be able to keep that water flowing and meet the basic needs of the people in the building. We're going to treat the second line just like the other service line, where it's going to need to have a main shutoff that has to be inside the building. There's a redundancy so that we can make sure the hospital can always have water. 609.2.1 requires that a tracer wire be installed for non-metallic piping. We're talking about this service line that we're installing, both the main and the secondary. We need to be able to locate those quickly. Now, most service pipes for plumbing will not require a tracer line. It's a great idea. If you put a tracer line in, you can find exactly where it's at pretty quick. But in these healthcare plumbing situations, it is required to have a tracer so that it's easy to find where the main lines are, where they run. For that tracer wire, access has to be provided. You don't just bury the wire somewhere, and it's got to be to where you can get to it quickly. They can hook up their equipment and find where the line is. It needs to terminate above ground, be at least 18 gauge wire, insulated type, and rated for direct burial. 609.3 goes over hot water requirements for healthcare facilities, specifically stating that any hospital fixtures, kitchen, laundry, they're going to need hot water. We should supply that. But it also states that if there are certain temperature requirements for healthcare equipment, we would need to meet those requirements. That might mean that we have to mix the temperature down, or get it to the exact temperatures that are required by the equipment. 609.4 talks about vacuum breaker installations within those healthcare facilities, and stating that those vacuum breakers will need to be 6 inches above the flood level rim. We'll see this in our presentation as we look at backflow preventers, but that's what this is all about, preventing backflow into any of these laboratory type fixtures. 609.5 talks about prohibited water closet and clinical sink supplies. Now, a clinical sink is like a water closet or a toilet. It just has a big square mouth. It's made for washing bedpans. Now, it's not uncommon for a clinical sink, or sometimes even a toilet, to have a separate faucet, like a mop sink type faucet, above that, so that you can hose out the bedpans, and then the toilet with the flush valve will flush all of that waste away. What this is talking about is that for both water closets and clinical sinks, you'll have basically that toilet or that bowl, and it's going to have a flush connection, so the flushometer valve, that's great. But any other supply, like that hose faucet, should not be connected at all to the fixture. This way the flush valve can still operate and flush the fixture clean, but anything else that would supply water is entirely not connected to the fixture. 609.6 talks about clinical hydrotherapeutic or radiological equipment. There's all kinds of equipment in a medical facility, but any of those that would require a water connection have to conform to 608. Now, we skipped 608, but that's talking all about backflow prevention. So in short, we just have to protect against backflow prevention from any of this type of equipment. 609.7 talks about condensate drains and the trap seal. They have to have some sort of water supply so that you can wash those condensate drains clean, and it needs to discharge through an air gap. Finally, on healthcare plumbing, we have 609.8. It talks about valve leakage diverter. This is referring to sterilizers and how you handle the situation with leakage inside of those. Moving on to 610, this talks about the disinfection of potable water system. Now, let me share with you my personal experience about why it is so important to make sure that our potable water systems are clean. I have seen this in multiple situations, both residential and commercial. I've been involved with rough piping systems where we're building it out. It takes time. It may take months on a commercial job to get the entire copper system done. But as the temperatures cool down, insects begin looking for a warmer place to be. And they like to go into open pipes. Now, not knowing this, we just carry on, build our systems. It's time to set the fixtures. In both situations that I've seen this, the water had been filled in the system, but of course, we turn it off to install our fixture stops. When I was cutting off the water pipes that were stubbed out of the walls to hook up the fixture stops, out comes the nastiest, stinkiest, black oozy stuff. Of course, I've got a catch bucket, but it smells absolutely horrid. Upon closer inspection, it is a pile-up collection of dead flies and whatever else they bring with them. Here's the thing, those flies go into the pipe and die, and I will tell you that they are the farthest thing from a sanitary creature. This is just one example of why it's essential that these systems are disinfected. We want to clean the inside of the pipes before we start drinking from them. And for that reason, 610 gives us some specifics about how you disinfect. When it comes to disinfection, it says new potable water systems shall be purged of deleterious matter and disinfected prior to utilization. Exactly what we talked about, right? You push everything out, you flush it, and you sanitize it. Here's how you do it. There are 4 steps. First, you flush the lines clean. Second, the system is filled with chlorine. Once that has been given time to kill anything and everything in there, the system is purged of the chlorine. And if that's not good enough, you can repeat the whole process. Now, how do you know if it's good enough? Well, there are water tests that can be done to prove that the water is free from anything dangerous. Specifically, when it comes to the chlorine to disinfect these systems, it gives us 2 options. You can put chlorine in at 50 parts per million for 24 hours, or 200 parts per million for 3 hours. So if you're trying to speed things up, just increase the concentration of the chlorine. You can use something as simple as chlorine bleach. You find a way to get that into the system, and as that feeds in, you purge that out to each of the faucets and fixtures so that you can smell it at the fixture That's when you know it's in. You turn off the fixture and let it sit. Once it is sat for the period of time, that's when you go back to the fixture, open the fixture, and purge it until that smell goes away. That's a basic way of handling disinfection. In 6.11, we look at point of use drinking water systems such as reverse osmosis. It basically tells us that we have to meet certain standards of water quality and that the waste should discharge through an air gap. Section 6.12 refers us over to the International Mechanical Code for more information about water heating solar system, whether that's for heating, domestic hot water, swimming pools, whatever else. The mechanical code's going to have more information about that. And finally, 6.13 talks about temperature control devices, stating that it has to meet a certain standard, the ASSE 1017. Hey, nice job. We made it to the end of International Plumbing Code Chapter 6 on water supply and distribution. Don't forget to watch the presentation on 6.08 where we focus on the backflow prevention. That one is a very critical section of this chapter. Also, make sure to check out the water pipe sizing presentation. All of these come together as we examine water supply and distribution systems. I'll see you next time.